Should be fine now. Uh, Hi, everyone. Today we'll be talking about the book, A Planet of Viruses. You can see here in my background. So the author is Carl Zimmer. I am glad to announce that he is with us today in this discussion. Hi, Carl. How are you? Good morning.
Good. Good morning. Hi. Thanks for having me.
Yeah, and thanks for being here with us today. And I am going to give some introduction about Carl. You all probably know by now who Carl is, but I'm going to give an introduction anyway. So he's a science writer, blogger, columnist, and journalist. He's one of the finest science essayists and communicators of our time. He writes columns in many journals and magazines. He's the columnist of the New York Times. His writings appeared in magazines like Discover, National Geographic. He has many books. Some of them are A Planet of Viruses that we'll be talking about today, Parasite Rex, Evolution, She Has Her Mother's Love. Uh, Carl, today I will be talking, probably the discussion will lean towards more like the current pandemic, but I will try to diversify the talk. So first, I have learned from your wiki page that you have a degree in literature, but you have become one of the finest science writers of our time. And I'm wondering what made you transform to a science writer, or was it organic to write about science?
Part of it was good luck. I was when I was young, I wrote a lot, and I thought I would somehow be some kind of writer when I grew up. And in college, I majored in English, and read a lot of great writers, and was working on my own writing. And I was always interested in science, but I didn't really think like, oh, I should become, that means I should become a science writer. It just didn't occur to me. But I got increasingly interested in journalism and applied to a few different magazines after college. And a couple years out of college, uh, there was an opening at Discover magazine, an American science magazine, and it was just for being an assistant, doing copy editing and things like that. But I thought it might be an interesting place to start, so I started there, just doing basic stuff, copy editing, proofreading, fact checking, that sort of thing. And I just really enjoyed the things I was reading about, and was learning a lot. And and it was a very nurturing atmosphere. They took good care of the young staff, and so I ended up staying there for 10 years. I ended up as a senior editor there. And towards the end, I was starting to work on books, and just started getting curious about other opportunities. So I was in my early 30s at the time, and it just sort of seemed like, well, if I'm going to make a move, now would be a good time. So then I started writing for magazines like National Geographic, The Atlantic, Wired, Scientific American, things like that, and working more on books. I started contributing to the New York Times, again, really focused on science, mainly on biology, a lot on evolution. Um, New York Times, I started contributing in 2004, and then about 7 years ago, they decided just to sort of formalize it and invited me to be a columnist. And so I've just been doing that ever since.
Nice, thanks. So we all know that Darwin was not only a great scientist, but he was a great writer as well. I was reading somewhere a few days ago that we don't have that many scientists in modern times who are great writers like Darwin. So there is a gap between science and and the common public, and the communication is not happening, and a lot of misinformation. spreads like fire this during this modern time.
Mhm.
What do you think? Why scientists are not becoming great writers these days? Are more focused on writing journal articles, scientific papers, and not writing for popular science at all, or they are not interested in writing popular science?
Well, I mean, you could say like, well, why don't I fly helicopters more? I mean, I don't know how to fly a helicopter. I never learned, and no one taught me. So, I mean, there's writing is just not something that happens automatically, and so I mean, I don't think anybody who struggles with writing should feel guilty about it. Like, it's not like breathing. It's just something that you learn to do. And I've actually gotten more involved on that side of things over the past 15 years, I guess. I started teaching science graduate students at Yale, science writing workshops, and then sort of graduated to teaching a seminar at Yale and so on. So I've done a lot of teaching, and I deal with a mix of people. Some of them are English majors the way I was, and they're working at the student newspaper, but they want to see what it's like to write about science and the environment and medicine. But then there are a lot of science majors or graduate students in science disciplines who, a lot of them, want to be or plan on becoming scientists or doctors, but they see writing as an important tool with what they do, which, as you say, is communicating with the public. And so they don't. There isn't much room made for in the training of scientists for that kind of an experience. There's not much. It's not built into the reward system, and it's certainly not built into the reward system for young scientists. If they do have a knack for writing or communicating, and they try to do that, other scientists will say, like, you really need to like get busy with your experiments. You're wasting time. So
Sure. Yeah.
I agree with you that it's really it is an important thing, but but there are clear reasons for it. I mean, someone like Charles Darwin or like Thomas Huxley, like they came from a different culture and a different time. Uh, you couldn't, in the 18, let's see what it have been, in the 1830s, when Darwin went to college, you couldn't major in biology. He just did this sort of standard sort of humanities type training. So he actually learned how to write. So did Huxley, but that's gotten eclipsed in the training of scientists.
So if you think scientists get trained in popular writing, they will be better communicators of science.
Yep. Yeah. They're like, if you just sort of go on your own intuitions of what makes for good writing, you may make a lot of mistakes, and you may make a lot of things that if someone just pointed them out to you, you could avoid them. There are many just basic mistakes, and I just see, I see them over and over again when I'm working with young scientists, with students. Like, there's an assumption that people can read your mind. There's an assumption that everyone knows the jargon that you've learned. There's an assumption that it's better to use passive voice. Scientists tend to shy away from telling actual stories, things like that.
Okay, thanks. Coming to your book, uh, to the readers and the audience, the book is divided into many chapters. Each chapter describes about one of the viruses, actually the groups of that viruses and their discoveries, history, and science behind it, behind them. So in one of your chapters, you have about the West Nile viruses that is spread all over US in probably 5 years when it first appeared, because it has uh, uh, intermediate host mosquito, and it's easy to spread by that. So you mentioned at the last of your chapter that the climate is changing, the environment getting hotter and warm, damp. So the hosts like mosquitoes can breed very well, and these kind of uh, infections will rise again and will be more widespread. And also in other chapters, you have also mentioned that the species jump of viruses is happening because we are uh, being close to the wildlife, catching them, killing them, eating them, etc. And the pandemic that is going on currently, we all know that the virus probably came from an animal host other than human. I'm wondering what we should do in future uh, if there would be 1 or 2 points so that these kind of pandemics don't occur again.
Well, scientists have been warning us about pandemics like the one we're in for 30 years. You can go back and see very clearly laid out warnings about what's happening. And a lot of it, they were discussing, viruses in animals wild animals that normally humans didn't come into very much contact with, but through environmental disruption, through hunting, deforestation, expanding agriculture, these viruses were more likely to spill over. That, back then, scientists didn't realize how many viruses are out there. And so now scientists have tools to go into a bat, for example, just a single bat, say in Bangladesh might have, there was one study where they just said, let's look at all the viruses. And I think they found 50 that could be, potentially things that might spill over into humans. That's a lot of viruses. And so, so you want to basically not provide so much of an opportunity for those spillovers. Climate change is another important issue for a lot of different reasons, not just for the disease issue. In some parts of the world, it won't make that big of a difference to the existing disease burden. But certainly, I live in Connecticut in the Northeast of the United States, and, we have some mosquitoes, but, there are a bunch of species that are down in Southern United States or Central America. They will be up here in the coming decades, and they may have diseases like dengue. So, whereas dengue has been a big problem in a lot of places for decades, it may expand to new ranges. So, for many reasons, including disease, we need to deal with the climate.
Yeah, one of the bad spreading disease was Nipah virus, and in our region, and it was really bad few years ago. And dengue is appearing every year, and you're right. They may be actually widespread if the climate gets hotter and hotter. And
right, and dengue is that's a virus we know about. Nipah is kind of a virus we kind of know about. It really hasn't. It really has. I mean, it seems to be one of these cases where it's coming out of animals into people, but it's not really. It doesn't really have what it takes to go from person to person to person.
Right. Yeah.
But that could change. I mean, if we have a highly transmissible Nipah, that's going to be bad.
Right. Okay, readers and audiences, if you have any question, please do now. I will ask many other questions by myself, but first, go ahead.
Well, I can probably start by asking a few questions by the time the readers submit more questions. So I would ask Carl about the current pandemic, and we know that you have been very vocal about the ongoing science journalism going on essentially everywhere, a lot in the UK as well, but quite prominently in the US, and linked with certain political movements as well. What do you think the scientists could do to counter this, or the onus is more on media to reflect the voice of scientists?
Well, you know, my experience with all this is really very much within the United States. So, you know, you would have to tell me, say, like what's going on in Bangladesh or the United Kingdom or other parts of the world. I wouldn't really be able to talk about what's going on in other countries with a whole lot of experience or context. But I mean, I started as a science writer writing about evolution. And in the United States, if you write about evolution, there are people who come after you, creationists. We have a very vibrant creationist community here, which, you know, has been around for a century because it comes out of a particular movement in American Protestantism and is still going strong. So I understand, I've had, you know, a lot of experience with how science denialism works and how professional denialists use tactics to create misunderstanding and spread disinformation. And yeah, unfortunately, like here in the United States, we're dealing with that right now. You know, first people were saying, "Oh, this virus, it's just a flu. Don't worry about it." Then they were saying it was a conspiracy by the Chinese. They had created it, ignoring the fact that there are all these other viruses that are spilled over in exactly the same way. You don't need a science fiction plot to explain this. Then you have the anti-vaccine movement who don't want to take any vaccine that we might be able to use, even though that's the only long-term solution to this. And right now, you know, we're dealing with the newest thing is masks, and we have people who are claiming that if you wear a mask, you're going to basically poison yourself with your own carbon dioxide. And I mean, they're like I mean, you can go on Twitter or the internet and see our town meetings in the United States where people are making these declarations. And it's very frustrating because it's like, you know, you don't need to be a scientist or a science writer to know that, you know, doctors wear these masks for hours and they don't die, they don't faint, you know, they seem to be fine. I mean, it's just, I mean, obviously it's uncomfortable to wear a really serious mask all day long. I'm not denying that, but just putting on a cotton mask or a cloth mask, there's a huge amount of disinformation. So it's very hard. It's very hard, but you know, scientists who have the expertise, if they, you know, if they can join in the public discussion, there are a lot of opportunities to do so on social media, for example. And social media can lead to being on TV or on the radio or writing. There's plenty of opportunity, but you know, again, scientists need to understand some of the basic rules for how to do that effectively, and they can end up doing more harm than good if they come off as being very arrogant, you know, if they seem to have contempt for anybody who disagrees with them. Those are just basic mistakes of communication that you have to learn about.
Yeah, you probably don't know, one of the best sellers in our country is actually a book denying evolution. So there is a huge work the scientists, the Bengali scientists, need to do actually to let people know about evolution, try to understand it, and they just said they don't believe evolution. So this is one of the greatest problems for us to actually teach the general public.
Yeah. We have a question from a listener, and this also links to what you have been doing, teaching science writing to scientists. And this question is about the other side, asking that, do you think it's useful to train journalists about basic science writing?
Oh, yes. Yes. And, you know, we are, we're in an interesting time right now where the most important story in our country and arguably in the world is a science story. It's a story about a virus. And so you have all sorts of reporters coming in and other people who are all talking and writing about viruses, and you discover that a fair number of them don't understand the basics about viruses, and also don't understand sort of how science works. The scientific process. Just because a scientist says something doesn't make it true. Actually, like there is a process of peer review, of debate, of testing people's hypotheses going forward. And so there will be a lot of sort of early COVID preprints that are just, if you look at them, you can see there's not very good studies, and small sample sizes. They don't present the evidence that leads to their conclusions and so on. That's not the end of the world that those things are out there. But if journalists jump on everything as the absolute revealed truth, it's very dangerous. It's bad for the public understanding of this pandemic. So yes, I certainly have been doing whatever I can with my fellow journalists who don't have, I'm interacting with a lot of scientists, journalists who have spent 20 years writing about politics or foreign relations or whatever, and they know a lot about how to report on those things. I'm trying to help them to understand this is how you write about science. There are a different set of rules.
Thank you.
Okay. In one of the chapters, you were talking about the bacteriophages and how bacteriophages were discovered. And then the scientist, he actually started a company out of one of the therapies, phage therapy. Now there is a greater risk of bacteria becoming more antibiotic resistant. We all know that, and we struggle to treat patients who are infected with such viruses that such bacteria that no antibiotics work against. Do you think the phage therapy practice has disappeared 30-40 years ago? So do you think those kind of therapies should come back and for treatments for the antibiotic resistant bacterial infections?
Well, we are clearly in a huge global antibiotic crisis, and when we deal with the COVID pandemic, we're still going to have this antibiotic crisis, which is killing more and more people every year, and it's just going to get worse because of evolution. I mean, because we are creating conditions that favor the selection of mutants, and these mutants get combine mutations in more and more potent ways, and so you're going to get to a point, if we don't change our ways, where doctors will just not have any solutions at all to a lot of infections. I mean, that's a very frightening thought. We've had a kind of golden age since the 1940s with antibiotics, and that age is starting to close. There are a lot of things we can do in terms of stewardship of antibiotics, using them properly to sort of lengthen them. But we need alternatives, and phage therapy, using viruses to kill bacteria, is one possibility. It is amazing. The story of phage therapy is astonishing, and I write about it in the book, about how over a century ago in World War I, Felix Durell, a Canadian physician, discovered phages in soldiers who he was treating who were suffering from dysentery, and then very quickly figured out a way to use them to clear infections. But he didn't do modern studies. He didn't do randomized clinical trials, and so it's hard to know exactly how effective his phages were and how safe they were and so on to use on a wide scale. So we are actually kind of going through a renaissance of phage therapy now. I've been curious about when I would get to report on phage therapy as a real promising solution, and it's finally taken till now. So I've been reporting on it. Other people have been reporting on it in the news. Like, there are more and more, really systematic cases. Governments like the United States are funding large-scale basic research and clinical trials, and I don't. It's not going to be a panacea. It's not going to be like the thing that takes care of everything. But I can imagine a future in 10 years where viruses are a regular part of how we deal with infections.
Okay, thanks. Anyone else wants to ask questions?
Well, it can
Okay.
take people a little while probably to prepare their questions. I will
Okay.
ask you about the other book that you wrote, and that's very close to my heart because it's my subject of research, the book on heredity. She has her mother's last. And thanks for the great book because I recommend it to a lot of people to understand in a more general public's approachable way about how our field works. So I would ask you that now we see probably in the US and many other parts of this kind of spectrum. On one end, we have people who are genetic determinists and say IQ and everything is determined by genes. And the other side, we have the blank slates. And of course, we can quantitatively talk about heritability as a number, but in general, in terms of thinking, where would your ideas lie about these things?
It's I think one of the reasons I wrote a book about heredity was because heredity is a word that you don't, as a science writer, you don't have to like define it for people. So if I would just tell people, if I was to say to someone, I'm writing an article about phage therapy, they'd say, what's that? If I say I'm writing a book about heredity, they'll say like, oh, like, let me tell you about my grandfather and how I have his ears. And, like they think they know what heredity is. And yet there's a complexity and a counterintuitive nature of heredity, which is so profound and so interesting. So that was the genesis for the book. Yeah, I mean, there's so many ways to take the research that you and others do on heredity and misunderstand it or use it to justify some ideology. It's very challenging. I think it's important to be reporting on new advances in heredity, even things that might be very controversial. So, for example, I wrote not too long ago about a study on educational attainment. How many years do people stay in school? And it turns out that there are a whole bunch, I forget how many genes they're up to, several hundred genes that they can link statistically to how long you stay in school. And that's scientifically interesting, and it's potentially important in a lot of different ways, but it's so easy to take it the wrong way. So for example, every gene, if you look at the contribution, it might, like on average, be, whether you have a certain version of that gene or not, might on average, count for like 5 days in school. It's like these genes have an incredibly subtle influence. And if you take all of them, they can only explain a small amount of the variation in how long people stay in school. So of course, the environment matters. Of course, your neighborhood matters. Of course, is your school any good? Of course, all those things matter. And to try to find a way to get people to see genes as part of the mix is very hard. Because if you start talking about genes, and people will either say, it's all genes, or people will say, how dare you talk about genes? You're a eugenicist, and you have these two extremes, and it's very hard to get people to sort of see the complicated middle.
Yeah, along with that, there's a taboo about studying races in scientific community as well. I was reading in one of the books, and it's really astonishing how people don't try to avoid any kind of research on races and connecting genes with that. I mean, we have different kind of people around the world.
Well, I would push back on that in the sense that, like, I write about race in the book, and I mean, the concept of race is a European concept that really emerged in the 1500s, not coincidentally with the rise of colonialism and slavery. So Europeans sort of came up with a sort of a way to justify to themselves that they were enslaving and colonizing other people. And they'd say like, well, there are these, we belong to a group, we're going to call them white or Caucasian, but it's a race. And there are the certain qualities inherent to that race, and there are going to be other qualities inherent to other races. Of course, no one ever seemed to agree on how many races there were, and what race people belong to. And so, like in Asia,
Yeah.
it's, if you looked at some European anthropologists, like they would say like someone in Bangladesh and someone in China were of the same race. But then others would draw different lines,
Right.
and that should be a clue that this whole concept of race was not really a scientifically valid concept. It's not that there isn't variation. Of course, there's genetic variation, and there's a whole history of humanity that produces that variation. We all arose from humans in Africa. Our species arose about 300,000 years ago. And then for a couple 100,000 years, it was pretty much a limited small population to that area. And then there was an expansion out into Asia, into Europe. And, as people settled in different places, they gained certain sort of a genetic signature. That's why our ancestry DNA tests work, because there are these genetic markers, but most of them are just neutral. They have no significance. And if you want to look at, skin color, which is like one of these icons of race, the reason I have very pale skin partly is because of a gene. I'm going to get the name wrong. I think it's SLC235. I'd have to look.
SLC24F5.
Got it. Right, that one. Okay, so I've got it. I've looked at my genome. I know I have this one. It's very common in Europeans. But the thing is that Europeans until 10,000 years ago were basically very dark skinned, all of them, and did not become light skinned until about 4,000 years ago. So that's very recent. Like there were humans in Europe for about 40, 50,000 years, and their skin didn't change until recently, and nobody knows why. And here's another thing, that variant that became very common in Europe, which I'm forgetting again, sorry. That's actually, you can find that across Africa. It's present in lots of Africans who, have kind of, sort of tan skin, in certain populations. So trying to draw simple lines around groups of humans and then calling them races is just, modern biology completely refutes that. And I mean, on the other, now, given that, like when you do start to write about, people having, sharing certain genetic variations, then yes, then that suddenly becomes controversial because people think you're a racist. But it's a job of a journalist to make it clear, like, no, we're not talking about these old wrong constructions of race. We're talking about the modern study of human genetic variation. It's not easy.
So going back to what you were just discussing earlier, that in anything, in genetics or in general any science, there is some sort of variability and uncertainty, and it's part of what scientists write about, that they try to quantify that amount. So a viewer was asking that when you see all these anti-science protesters, they are extremely confident with what they're asserting, like what we saw in the town hall you were mentioning. But when scientists are writing about, are they handicapped in some sort of way, or they just need to be more assertive?
That's a really good point, because science, for science to work properly, there needs to be some humility. Like you need to be careful about talking about what you know and what you don't know yet. But I think it's I think you also need to be aware that of the implications that people may take from the way you express that humility. the thing is that scientists, I find scientists really like to be right at the edge where we don't know a lot, where there are just lots of questions to answer. That's the fun place to be when you're a scientist, because you can find something out. And then when you find that out, then you're like, okay, well, what's next? Like, where do I go from here? What's the? Let me go further into the fog. So you sort of forget about all the stuff that is now well established as science. So if you're so focused on that, and people hear you talking only about being at that edge, that foggy edge, then they might think that everything is uncertain, that you don't know anything. And so if somebody comes along who sounds very assertive and certain, then, well, they're going to say like, well, this person has things figured out and those scientists don't know anything. So, you know, I mean, for example, you know, scientists are still trying to work out the details of how the Earth formed in the early solar system. You know, how quickly the core formed, how quickly the mantle formed, how quickly the crust formed. So we don't have answers to some of those questions. Now, does that mean that we don't know how old the Earth is? No, of course not. That's one of those kind of, for you as a scientist, one of those kind of boring things. Like, yeah, we know that. Like, who cares? It's 4.56 billion years old. Like, yeah, fine. I want to, you know, for my research, I want to figure out, when did the core solidify? When did we get a magnetic field? You know, how quickly did that happen? So you just have to remember that when you're engaging with people who are not themselves scientists.
Okay. Anyone else wants to ask any question?
Thank you
Kabir?
very much. Yes, I have two questions. Thank you very much for giving this floor. And my first question is about World of Virus is a project of University of Nebraska. And is this project still going on? And Carl, are you still working with this project? And if yes, any research is happening related to COVID-19? My first question is that.
Our connection is bad. And so I'm having.
I can rephrase it for you.
Okay.
He's asking the book, A Planet of Viruses, is about one of the projects called The World of Viruses, probably.
University of Nebraska.
The essays you have written that appear in this book. So he's asking if the project is still going on.
Right. So this book originated in an educational project I was invited to be a part of, and I was writing just a series of short essays that would be part, you know, educational materials that teachers could use. And after I'd written like a dozen of them, my colleagues said, like, I think you've written a book, and I was like, that's interesting. And so they went to the University of Chicago Press and said, you know, we have these essays that Carl's written as part of this project. Would you be interested in publishing this as a short book? And they were. So the first edition came out in 2011. And then in 2015, the University of Chicago Press came to me and my colleagues and said, you know, there's been a lot of news about viruses. Could we update it? So the second edition came out in 2015, and sadly, now we have a lot of new stuff to talk about. So I'll be working this summer on a third edition of the book, which should come out, sometime early 2021. So does that answer your question?
Yes, and I have another question. I would like to ask you, you as a researcher journalist, when you watch that X university discovered the medicine help related to COVID-19, or Wuhan, China's food style is responsible for this COVID-19. How do you approach this thing?
How do I approach reporting on COVID-19 medical research?
Yes.
Well, I'm, I've only been, well, this is a challenge, and it's a new challenge. Let me put it that way. I don't have any great answers for you because I'm still figuring it out. I was, in January and in February, I was working on another book, trying to finish that up. It's a book about life and what it means to be alive. And I was actually trying to like slow down my newspaper reporting so I'd have more time to work on my book. But obviously in February, it became clear that what we were dealing with this virus, and then the newspaper and the New York Times really basically tried to pull as many people as they could into working full time on reporting on COVID-19. And so I joined that effort in the beginning of March. And it's one of the challenges is that, it's good in a way, is that we have a global, scientists around the world really are trying in a global way to understand this virus and to come up with a way to treat it. So there's a lot of news, and it's really hard to figure out, what we as a, a relatively small group of people can write about. We're writing like crazy. Like, we will be writing several articles a week about new scientific findings about just about COVID-19. And so it's crazy. But part of what we do is like, as you, some of us, try to do to gain more of our own understanding of different fields. So, with, a big issue has been the science of testing. What makes for a good test for this virus? And, you really need to understand, you really need to sort of sit down and really understand PCR and all the ways that PCR can go wrong to understand what makes a good test or a bad test. And then after a while, you can, if someone sends you a press release saying like, oh, we have a brand new test, you can look at it and say like, you can tell that's not very good, and you just ignore it. I've been trying to develop other ways of keeping up with the news. So with vaccines, for example, the World Health Organization has identified, I think 130 or 140 different vaccine projects around the world. And 13 of them, I think now are in clinical trials. So we decided to, rather than try to write about each one individually, and nobody could keep track of that, we just sort of created a central web page, what we call a vaccine tracker. And I and some other people, we just keep track of all the news on all the vaccines, and try to sort of present that in a clear, compelling way. And we just keep updating it several times a week because things are moving so fast right now. But it's definitely a work in progress. And I've definitely, I've written things about our research that I've looked back and said, like, I think I was a little too much in a rush. I was, a little too eager to grab a story that in hindsight was not that important. So I'm trying to learn. And unfortunately, I think this will be what I'm writing about mainly for at least another 6 months or a year. I don't know.
Thanks. Related to that, I know that during the pandemic, it is a challenging time for the journalists as well, because the things that are changing so rapidly. For example, the hydroxychloroquine stuff that has been retracted from two of the very well-known scientific journals, and then the journalists also had to report these things, but they came out to be false. Yeah. So how do you deal with these kind of things from your journalistic perspective?
Well, the science journalism community had already been dealing with this general issue before COVID-19. I would say in the past 5 or 6 years, it was becoming clear that that there was a small but disturbing amount of scientific literature that was getting retracted because people were being sloppy. Some people were, committing fraud. They were duplicating images, or they were just going into spreadsheets and just changing numbers. And in addition, studies, people would replicate studies and then discover that these very famous results were not true.
Right. Yeah.
And like, I think science journalists, we had to sort of like recognize that this was a serious problem in the scientific community, and that we weren't like saying like, oh, science is bad, but we had to sort of like look at this movement within the scientific community itself to really say we have to do a better job with how we do science. A lot of scientists didn't like that we were doing this. I mean, I wrote about this for the New York Times, Ed Young wrote about it for the Atlantic, others have written about it in other places. And we would get a lot of criticism, like, oh, you're making us scientists look bad.
Right.
And I'm like, well, no, scientists themselves, a lot of scientists themselves are concerned that there are, really famous people in their field that just are committing fraud. So we were kind of we were aware of this as a problem, and I think we've done okay with that at least, like, we know how this goes, and actually with the hydroxychloroquine study, the reason it was retracted was really sort of, I think, a combination of social media and journalism. That people looked at that one of those studies and they're like, wait a minute, like, you're listing, if you drill in and just look at the numbers, you're like, they're listing more cases in Australia. They claim to be treating more people in Australia than actually even had COVID. There was something wrong. And, reporters would look into this, scientists would look into this, and pretty soon there was just a growing outcry about this. And then a bunch of scientists wrote an open letter to the journal, which we reported on right away. And then this thing got retracted. I mean, let me put it this way. It is horrible that there's sloppy science that's getting accepted into major journals about a pandemic. That's not the fault of journalists. That's the fault of scientists who are so eager to do something, to do some good, that, as reviewers and editors of journals, they're like, let's get this in fast. Let's get this in fast. This is important. Let's get it in fast. And let's not take the time to really look at it carefully. This was a big mistake on the scientific community's part. But I think overall science is being self-correcting in this case. I mean, I think, that study you mentioned was showing that hydroxychloroquine was not effective and actually had some dangerous effects. Fortunately, like that turns out to be true, but you didn't need that one study alone to know that. There's lots of other studies have found that as well. And so science as a whole I think in that case is moving in the right direction. It's just unfortunate that one paper really put a blight on the field.
And Nasreen, you have a question?
Yeah, my question is regarding vaccination. As I'm following Carl on Twitter and I'm watching him like tracking the vaccination process for COVID-19, the vaccine process. My question is basically, now that there is actually a developing group of anti-vaxxers out there, at the same time, different companies and different research groups trying to develop vaccine for COVID-19. What do you think, or how do you think, like, if we can get a vaccine against COVID-19 pretty soon, let's hope for the best, finger crossed, how to deal with this anti-vaxxer community, like knowing they are not really eager to, and seeing how they can go very aggressive in terms of just using masks. So I cannot really understand how would they take this vaccination and process, and if a large amount of people don't take this vaccine, how can we deal with the situation? And as a science writer, what do you think, like, other science writers and your role in this context?
That's a really important issue. So for myself, what I'm doing is I am trying to write a lot about vaccines, and I want to be writing going forward about how scientists develop vaccines. How does it work? What are the stages? So that the sort of very radical anti-vaccine movement takes advantage of a very understandable impulse that parents want the best for their children, and if they hear a story about some people putting shots in kids and then something bad happens, then they feel like, well, my first priority is my child, and or maybe I'll just wait, or maybe I can. It's better not to have that. And so I think that if there are people who have that sort of uncertainty and hesitancy, I hope that my reporting can make them understand, like, well, how do scientists know what they know? How do they know that vaccines are safe? Well, it's not just just giving one person an injection and seeing what happens. It's large randomized controlled trials. That's how it works, and to explain why that's how it works. So that's what I'm doing. It's going to be the anti-vaccine community is very well organized and really ready for this fight, at least in the United States. And I am, that could be a big problem. On the other hand, the really strong anti-vaccine community is very loud, but it's relatively small in the United States. That can be a problem when you have flare-ups of measles and so on. But it could be that, like, if we were to get, like, in the United States, like 80% coverage with a really good vaccine, I think we'd have herd immunity, and so you might have a very loud minority yelling about it, and then everybody else just says, like, go away, I'm getting my shot, goodbye, and then we'd be in a much better place than we are right now.
Thanks.
As we are on this topic, just another quick question. Who will get the vaccine first, like the developed countries or developing countries like ours? Who will get the vaccine first?
That's an important question, and I can't tell you in advance. And I will say that there are there have been there are organizations that have formed over the past decade, but again, before the pandemic, who had said, our system of vaccine development and distribution needs a lot of work. And one problem is that for any disease, developing a new vaccine had been very difficult. But it was mainly difficult because not because vaccine development is mysterious. It really isn't. It's pretty straightforward, but it's expensive and takes a lot of work. And so you would have, case after case, you would have people creating a new vaccine, testing it out on mice or even on monkeys, getting some good results, and then they couldn't get anybody to help them carry it forward into clinical trials because those are expensive. We're talking, in the tens of millions of dollars kind of range to run these things. So vaccines would fall into what developers would call the valley of death. They couldn't get out of there with strong results that could get them licensed. These big drug companies really looked at them as risky, very risky, and just you could go out of business. And so so there are these organizations, CEPI and Gavi are a couple of them, that have basically said, like, okay, how can we cross the valley of death for lots of diseases, and so now they're applying that practice to the pandemic. So there are, so there actually are large scale programs that are, getting funding. They still need more money to get this vaccine out, distributed as quickly and as fairly as possible. They estimate on yesterday they had a meeting where they estimated they're going to need $30 billion to do this, which is that's a lot of money. But here in the United States, we just gave away about $3 trillion, mostly to large companies because of the economic crisis here. So in the scheme of things, if you have a virus that has been destroying trillions and trillions of dollars of economic value worldwide, $30 billion is nothing. So so I'm hoping, I think we should all hope that that effort really gets off the ground.
Okay. We are close to the end of our discussion. I will take 5 more minutes from you, Carl. Is that okay?
Oh, sure.
Okay. In the last chapter, you mentioned that in 2000, the International Committee of Taxonomy of Viruses declared the viruses are not living organisms. And then it's about the mimiviruses, which is who outlier among all the other viruses. It's a big virus, have a big genome, and you counter-argued that actually viruses can act like living organisms. So we trained in microbiology. My bachelor is in microbiology, and we had a favorite topic to argue about: is virus a living thing or not? So what's your view on that?
Well, it's a question that I really enjoyed thinking about and talking to scientists about. And actually, my next book, it's called Life's Edge, and it'll come out in March 2021. And basically, what I do there is I kind of explore that boundary zone, that gray zone where we're trying to figure out are things alive or not? When do we become alive? When do we die? If you look at a virus, is it alive or not? It's surprising to me how readily people will just dismiss viruses, like, nope, not alive. And if you really drill in, you can uncover a lot of philosophical issues, like, well, okay, well, why not? What is the definition of life that you're relying on? Do you have a theory of life? And then things get much more complicated and much more interesting. And you mentioned, for example, giant viruses like mimiviruses. These are huge. For a virus, they're gigantic, and they can have thousands of genes. And some of those genes are encoding for things that we think of as being hallmarks of life. Genes that are involved in translation and protein synthesis. What's a virus doing with that? And so so I personally think that maybe trying to define things as life or not is actually a philosophical error. And that if you develop a theory of life, then viruses are very much a product of that living process. So I would at least say they're a part of life.
Thanks. One of the questions appeared in the Facebook page that do you think the vaccination is the only way to eradicate viruses? And given that there are more technologically advanced strategies scientists are developing, for example, the CRISPR-Cas9 or other kind of therapies, do you think we should solely rely on vaccination to stop any kind of pandemic?
Well, you know, it's interesting. It's an interesting question because so COVID-19 is caused by a coronavirus, which is very closely related to the virus that caused SARS in 2002. They're different diseases. They're both respiratory diseases, but they're different in the sense that SARS has a much higher mortality rate, but doesn't do as good of a job of spreading. And your symptoms come on much faster. So like you're infectious when you're coughing and have a fever and so on. Whereas with COVID-19, you can be very infectious before you develop symptoms, so you don't even know it. So SARS broke out in China and then spread to Hong Kong and other countries, came into Canada, never got to the United States. I don't think it got to Bangladesh.
No,
I mean, it got to
we
some.
haven't got, yeah.
Yeah, I mean, it got to a couple parts of Southeast Asia, but anyway, but it only, like in total, it only infected about 8,000 people. And then, but basically we figured out, oh, you just need to quarantine these patients, be really careful not to and find everyone that they're exposed to, quarantine them, and it just burned itself out. We didn't have a vaccine. We still don't have a vaccine for SARS.
Right.
And we got rid of it. However, where did it come from? It probably came from Chinese horseshoe bats. And there's no reason to think that it's not out there, either in the horseshoe bats or in some other animal reservoir. So they could come back. So, so quarantining or using an antiviral, we definitely need to be pushing forward with those things when we can. But really, vaccines are really special because what they do, you can give them to everyone if they're safe. And then basically you get everyone's immune system to learn how to fight it when it shows up. So you're not having to treat people after they get infected. In theory, everybody's covered. Smallpox is not an issue for us anymore, thanks to vaccines. Diseases that were once common, like polio, are now extremely rare, thanks to vaccines. So I really do think that we need to look to vaccines as being the long-term way out of this.
Nazma, you want to ask a question? Nazma?
I think she went offline.
Okay. Kabir?
Okay. Yes, I have another question.
Yes.
What do you think about conspiracy and virus business policies? Sometimes what we see in Hollywood movie.
What do I think about viruses in Hollywood movies?
No. What do you think today's situation, vaccine business policy?
Oh, vaccine business policy. Is that right?
Yes.
Yeah. Yeah, that is a very good question. And so it's, it's always, I find that it's good to, in these times, to go back and read about Jonas Salk and his invention of his polio vaccine. He did not patent that vaccine. But when asked why he didn't patent it, he said, well, this is for all of humanity. We need to be aware that that is a way of making vaccines. Right now we have, companies that are dealing with vaccines and as business propositions, and we should be concerned, and we should be, an important thing for us journalists to do is to follow the money, to show what's going on with the money. So that the New York Times, for example, my colleagues have been reporting on, there's one company called Moderna, which is developing a very experimental kind of vaccine for COVID-19, which uses messenger RNA. The company has gained a huge amount of attention because they've been so fast to get their vaccine into trials. And so their stock price has gone way up. And they were able to get like this very initial data on 8 patients, eight, I should point out, just 8 patients. And the stock price went through the roof. And a lot of Moderna executives have been cashing out on their stock at this high price. I'm not sure that's the best way to save the world. Now in fairness, like that, there are other companies and universities and organizations that are not following that path. But that's just one example of behavior that we need to really, we need to shine a lot of sunlight on these kinds of behavior. So that's going to be a lot of our reporting at the New York Times going forward. Like what's the money? What's going on with the money? And there's a lot of money coming to these companies from governments. So the United States gave, I think, $1.2 billion to AstraZeneca for their adenovirus vaccine. Could be a great vaccine or not. We need to be making sure that we get the best vaccine rather than the one that has the highest stock price.
Nazma, you wanted to ask a question? Nazma? Okay, anyone else? We are close to the
sorry,
end.
I was.
Yeah, okay,
Hi,
okay.
can you hear me now?
Yes.
All right. Sorry, I had to go offline. It's a rather controversial question, and we all know, and then I believe that this coronavirus or the COVID-19 virus is not a lab made, but I would like to hear from Carl Zimmer that what's your thought about that? Is it a lab made virus or is it a natural virus? Like, I believe that it's not a lab made one, but what's your thought on that?
It's not a lab made one.
Yeah, it is not. So, but there are a lot of, like, I am tired of hearing this. Like, there are so many ideas that people have. Like, I don't know where they're getting all those ones.
Well,
I don't know. Have you heard anything? I'm pretty sure you've heard.
Oh, no. Well, here in the United States, you can get it from our highest officials in government. It's really it's a very challenging situation when you're in the business of writing about science and facts about science. When you have the Secretary of State or a US Senator intimating that, that things were created in labs, or, it's sort of, these conspiracy theories have shifted a little after, after the lie that it was created in the lab came out. Then some people said, well, no, or maybe it wasn't created, but it escaped accidentally from a lab. They would, and that's, if you want to say that, let me put it this way. Yes, viruses have escaped from labs. We have evidence of cases where viruses escaped from labs.
Mm-hmm.
There was a flu outbreak in 1977, I believe, which probably was the result of a Russian lab letting some flu strains slip out. Like the idea itself is not crazy, but you have to give the evidence. So what is the evidence? And that's where everything falls apart for these people. Like they cannot give any evidence. They can say like, oh, well, somebody complained that this lab was kind of careless, a couple of years before, something like that.
Right.
you know, like, and it's just like Occam's razor, it just tells you that this is a spillover, the same kind of spillover that's been happening for 100 years. And that's, you know, what I read about in Planet of Viruses. I mean, HIV, SARS, MERS. I mean, the list goes on and on. West Nile, we mentioned. I mean, the list goes on and on of viruses that started out in animals and then wild animals and then got to humans. You don't need a lab to get you sick. And you know, we can see that this, you know, if you go and you look at, you know, if you go to China and like test people, like go to a bunch of farmers who live around some of these bat caves and just draw their blood and check for antibodies, you find that they have antibodies to a ton of bat coronaviruses. So like, again, like the most plausible explanation by far is that this virus jumped from a bat to a person and then was off to the races. And it is very, you know, that is dealing with these particular kinds of conspiracy theories it's hard work for a journalist, but I think it's one of the most important things you can do. Because, you know, if you think like, if people think like, oh, this is just like, you know, the only reason we're dealing with this is because, you know, some foreign lab was sloppy, then you're not going to be worried about the COVID-23 and the COVID-28, because you're not realizing that there are so many viruses in bats and other mammals, you know? So it's really important that we get this across, but I think it can be done.
Oh,
but I would
sorry,
appreciate
we're running
that
quite
you
out
just
of time, so I think we need to wrap up. So I think Atanu had a last question, then we can wrap up.
Yes, thanks for the conversation. I'm a big fan of your work, sir. Your Planet of Virus motivated me to enter into virology. So actually what I want to know, there is, as we all know, that it's COVID-19 started from China. So yes, we also know that it's not a lab-made virus, but what do you think about that, holding the information of this COVID-19 patients' data from all over the world, that China hold the information? So what do you think about these activities of China? What do you think that about this action?
Well, I mean, I guess it depends on what question you're trying to answer. You know, so here in the United States, you know, I mean, I think it's quite obvious that we have failed badly at dealing with this. You know, we have over 120,000 people dead in this country. We've got over 2 million people infected, and the cases are going up, not down. We have failed. So you cannot go and blame China for that failure. Why is it that New Zealand has succeeded where we have failed? Like, you know, if New Zealand can do this, then the United States should be able to, you'd think. So, so trying to blame China for things that our government was responsible for is just dishonest, frankly. Now, that being said, if you look at, you know, reporters, journalists at the New York Times and at other newspapers have looked at what China did in the early days of the outbreak, and they found lots of terrible decisions and really harmful ones, you know, of hiding information, of punishing people who spoke out. You know, this would have been a much smaller pandemic if China had dealt with this quickly and transparently. We lost weeks as a planet. We lost crucial weeks. You know, on the other hand, you know, the genome, you know, Chinese researchers put the genome of this virus online January 10th. So, you know, that kind of information has been out from very early on. It's just that, you know, country, you know, our country, you know, couldn't get a test working until March, you know, well after our country was flooded with the virus. So yes, I mean, I think that, you know, China has a lot to answer for, but countries like the United States can't blame their terrible mistakes on another country.
Thanks, Carl. We
Thanks
are
for the
close to the
answer.
end of our discussion today, unfortunately. I'm looking forward to read your next book, Life's Age. And I have started reading the She Has Her Mother's Love. And I hope you will appear again in our discussion with that book. I'm looking forward to it.
I'd love to. Yeah, that'd be great. It's been really fun talking with you all.
Thank you.
Thank
Carl.
you for being with us, and thanks everyone who participated and who watched it on Facebook. Thanks.
Thank you.
Bye.
Bye.